Hi everyone, this is Dr. Vishal Sharma of the Carry Ethernet Group coming to you with part 2 of our CE Live for today. So as many of you know, we had a wonderful CE Live this morning with 3 guests, Hashim Kroser from South Africa, Larry Samberg, who was coming to us from Boston, and my good friend Paolo Volpato, who came from Italy. And we had a wonderful discussion about some architecture issues, some traffic management issues, and a very interesting question that Paolo had raised. And there were a few other topics that I wanted to cover that were very pertinent to, I think, the state of the industry, to what has been discussed in the Carry Ethernet group in general, and to what I think would be of great interest to the large population of telecom practitioners that we have on the group and that may view this video at a later point in time. So for the benefit of that, I thought I'll quickly make a second video, a part 2, if you will, and walk you through some of the things that I couldn't do the first time around. So let me share with you a quick outline of what I am intending to do right now. So the thing that we really wanted to cover this morning were 5 ways for telcos to innovate, which actually was covered in part 1. What I really wanted to talk about next was QoS standardization initiatives, which I think are important for people in the industry to be aware about. There's a lot of activity going around QoS again. It seems to have seen a resurgence after many, many years, and for good reason, because of the multimedia traffic that both wireline and wireless networks are seeing a surge of right now. I definitely wanted to discuss the new FCC report and the upcoming rulings that are slated to come out of the FCC later this month, the FCC being the Federal Communications Commission here in the US. And we talked about the IoT boat and what's rocking that, and why telcos haven't looked at it. This was all covered in part 1. But today, this evening, I would like to cover something about NFV. No discussion today can be complete without SDN and NFV. So I want to talk about the notion of VNFs as a service that Tom Knoll advanced in one of his blog posts, and I wanted to dig a little bit deeper, give you a flavor for that. Cover a little bit of the NFV wars that are clearly ensuing between Cisco and VMware, some things you need to be aware of in terms of the strategic direction of the industry. And talk a little bit about what virtualization means. That's not NFV specific, but we'll talk about different ways to virtualize, which comes from a very interesting blog post by another gentleman, which I will talk about when I cover it. And finally, I want to talk about data center design, a very short look, and the value of small cells. So let's kick off with QoS standardization. This was actually a very interesting discussion interview that was posted on the SDN Central blog, and I want to actually screen share and show you that while I talk through it. So this was an interview that Roy Chua of SDN Central did with Pascal Menzies. So let me talk about that. So Pascal actually is currently program manager for Skype for Business at Microsoft, but really more importantly, he's the chair of the International Multimedia Telecom Consortium, which stands for IMTC. And there's a link to that from the mind map that I use always to kind of walk you guys through the various developments in the previous 2 weeks. Now, what IMTC has been doing, for those of you that may not know, that a few months back, they released a version 1.0 of their QoS specifications. And then just recently, they released the Automating Unified Communications Quality of Experience version 2.0, which basically covers their QoS use cases and specifications for what they want to see in the UC community for QoS. Now, the reason they are working on a use case spec to automate diagnostics using SDN is because many UC problems, many UC performance problems are eventually all caused or can be traced back to an ineffective matching of the underlying network and its characteristics to the requirements of UC applications. So the IMTC and the ONF have been working very closely together on a standards-based end-user application northbound interface that will allow the UC applications to talk more effectively with the network, thereby giving better visibility, control, automation, and agility. And these are all buzzwords, we all know them. But let's talk a little bit more about the details here. So really what Pascal talks about is that you need QoS, which is very, very essential for real-time communications, because delay, jitter, and packet loss are extremely important in real-time communications. The reason is that you cannot tolerate a lossy environment. You cannot tolerate TCP/IP's retransmission-based environment when you have something like HD video being transmitted at 1.5 megabits per second per stream. So even if you have forward error correction techniques like packet loss concealment or FEC codes, they really don't work when you have burst errors. And this is an observation that was made in one of my other videos when we are talking about what happens with performance management in TCP networks. So the reason they want to standardize this QoS framework is because it gives the ability to control the prioritization of classes of traffic under congestion. So you have some uniform way of doing that as specified in these upcoming standards. And this is particularly important for Wi-Fi networks and for slow WAN links. So what does 2.0 have in terms of use case beyond the use case specs? Well, it has two important things. One is that it talks about admission control, where the idea is to regulate access to the shared network bandwidth across all of the cause or class of service classes on a session by session basis. So the framework introduces the notion of admission control on a per session basis. And then they talk about dynamic traffic engineering, which essentially regulates the allocation of the total link bandwidth and link capacity to different classes of service and provides a way for path selection based on how much residual capacity you have available on a link. So these are two important characteristics that are covered in this new framework, and I wanted you guys to be aware of it because there's a lot of different developments happening in the industry, and these are some of the key ones being shaped by people who are in the unified communications community. So there are two developments going to happen in parallel that will come out later this year. One is the Unified Communication SDN use case spec that's going to be released by the use case working group of the IMTC. And in parallel, the ONF is going to release its real-time multimedia northbound interface, real-time media communications northbound interface specifications. Both are expected in the middle of this year. And what this will do is that it will provide some, as we said, framework for standardized ways of looking at prioritization of service classes under congestion conditions. Now, one more important point that was covered here is that the current deployment challenges in implementing this model is essentially that encryption makes it very difficult to classify real-time media sessions. And if you want to do sort of deep packet inspection, that can be complex, it's costly, it's unreliable. So the solution that the IMTC is proposing is to have an out-of-band API that can allow the end user apps and the network to communicate with each other. So you don't actually have to sort of snoop on the traffic to try to figure out what real-time media traffic is actually going on the network. And then the next issue that Pascal hinted at, which I think is worth noting, is how do you have a migration strategy for, especially in the enterprise networks, in the access and campus networks. And a good point made by Pascal was that using an SDN controller, and there are many SDN controllers on the market today that provide a whole slew of southbound interface options to talk to a variety of different kinds of legacy gear. So if you were able to use an SDN controller, then you could have the option to talk to your legacy gear, so you don't have to throw all of that out. And at the same time, you could start migrating your network to new equipment that was more SDN enabled. And this is particularly important in Wi-Fi, where, according to Pascal, Wi-Fi access points are expected to become OpenFlow enabled very soon, and that will allow a lot of SDN enabled capabilities to be programmed to these access points. So in a nutshell, this is what is happening in the world of unified communications with respect to core standardization. Now, the other topic that I wanted to cover, folks, is some recent rulings by the FCC. And what has happened there? So, well, the FCC earlier this month, or actually end of January, came out with its 2015 broadband progress report, and it pretty much redefined broadband. So broadband used to be 4 megabits per second download and 1 megabits per second upload. But the FCC changed the definition to now make it at 25 megabits per second download and 3 megabits per second upload. Now, what does this mean? Well, ostensibly, this was done by the FCC so that it will spur competition among broadband providers. It will motivate broadband providers to actually provide higher levels of service and better broadband access. But there's some interesting consequences to this, and let me list some of them for you. The first thing that happened is that by this new definition, almost 35% of the schools in the US no longer have broadband access because they don't have these high speeds. And almost 17% of the US population essentially lacks access to broadband. Some of them are in the rural areas, but some of them could even be in areas like Silicon Valley. I mean, I don't have, by this definition, a broadband connection from Comcast. So this is very interesting. It creates a dichotomy in terms of who actually has broadband access. And just to give you a sense of that, there was a very nice IEEE publication that showed graphically what happens under the new and old regime. So right here, you'll see that under the old regime, almost 60% of the population, this is wired access only, had access to at least 2 providers as an option for broadband. But the moment you change the definition to what we have now, almost 55% of the population has only one provider. So essentially, it's a monopoly in many markets. And that's the consequence of this definition. Plus, as I said earlier, this creates a problem also for people like Comcast, because under the new faster speed regime, what it does is, in many markets, it gives Comcast a larger monopoly of the broadband market under the new definition. And this may have some interesting consequences for their merger with Time Warner Communications, because the merger becomes more difficult. There's more monopolistic threats that are possible now. And by some estimates, 63% of the population will be covered by this merged company. And if they don't have any choice for broadband, then we have a competition problem. Now, the other issue I wanted to talk about is explain a little bit about net neutrality and the divide between the internet companies and the cable companies. So what's really going on essentially right now is that the internet companies, the Googles, Yahoos, Facebooks of the world, actually favor a very strong net neutrality regulation that will keep access open to anybody and everybody without discrimination. But the cable companies and the telcos, who actually build the plumbing, who have the infrastructure, have a different take on this. They want the FCC to not regulate a broadband and to not classify it as a regulated service, as a utility essentially, under Title II of the Communications Act of 1996. Now, were the FCC to do that, what it would mean is it would have several consequences, which would essentially eliminate competition, and it would create a problem for free access to the network for the Googles of the world. Now, why would that happen? Well, basically, what would happen the moment you classified broadband as a regulated service, some things would come into effect. It would essentially ban operators from blocking any traffic from their network. That means equal access to all. It would ban them from throttling traffic on the network, which means they would have to again provide equal access to, let's say, video traffic from Netflix as they do to any other traffic. But then video traffic is a big hog of traffic, and that can change the dynamics of how the operator has to actually provision and capacitate its network. And it would also essentially end paid arbitration. Paid prioritization of content. And now this is something that Netflix actually did. They were paying some of the access providers for access to their access links, which would not be possible under this new regime were it to come into effect. So the key points of the new FCC regulation, which have leaked out so far, are that there would be equal regulation for all for broadband, which would basically mean that there's no discrimination against any lawful content. As long as you have lawful content, you have full right to use the access and metro lines of different providers to reach the end customer, which is great news for the over-the-top providers, but obviously not so great news for the actual operators providing the plumbing. The second thing it would do is it would allow the FCC to hear complaints about ISP interconnect and peering, and that's very interesting because that would allow the access providers who are currently charging Netflix, Netflix or other companies that are paying for prioritization could then go and demand that the FCC arbitrate that and potentially remove those charges. And that, of course, doesn't augur well for the standard access providers. The other thing the FCC could do is it could impose rational settlements on the internet. But unfortunately, since they are not allowing for paid prioritization, it really doesn't mean a whole lot, because there can be, the only settlement you could have then is based on a peering arrangement that doesn't involve transfer of exchange of money. And they can also sort of have some regulation over what are called non-internet services, which include things like IPTV and voice over IP. So the idea is that so that they don't kind of undermine the net neutrality notion. And but that's really a bad thing, because if under net neutrality, a lot of the operators tend to go to unprofitability, there's only so much you can do to regulate that. As Tom Knoll said in one of his blog posts, you cannot really regulate unprofitable operations. And so operators are going to be forced to come up with means to get around this somehow. Now, what this really means, the other thing I want to point out is that the FCC is having an all-encompassing view, and they're including both wireless and wireline broadband. So basically mobile broadband data services under the gambit of this new regulation. And as you can imagine, that's strongly protested by all the wireless associations, by the CTIA, and so forth, who believe that it's going to hamper competition. But the point that we as networking specialists and the network equipment companies need to focus on is, what does it mean for networking? Now, if you regulate equal access to the network, then essentially what you can imagine is that sophisticated QAs could have a smaller role to play in the network. I mean, there'd be no incentive for an access provider or metro provider to actually provide prioritized service and prioritize differentiation of traffic, because everybody has equal access. So there's really no, I don't get paid for prioritizing traffic, because I can't charge a person like Netflix or the end customer for prioritizing their traffic. As a result, I have no incentive to do that. But that basically means that sophisticated QAs, as we know it, could potentially become something that the operators are not really very keen to use. And that puts all of the activity back to the cloud and potentially to layer one below, kind of emptying out the need for traffic management at L2 and L3, which doesn't really augur well. So this creates an interesting situation, and we're going to find out more on Feb 26th when the FCC regulation actually comes out. Now, as somebody observed in one of the blog posts, the problem with this kind of a model is that there are a lot of different companies today that combine some element of transmission in their offering their service. And so with this kind of a regulation, the FCC could potentially regulate any company that does that, and that has some amount of transmission as a component of its services, and that kind of makes the FCC's regulation very broad and all-encompassing, which is where all the furor is. So that's the second point. I just wanted to sort of update you all on the goings on. I think this is going to be an interesting battle to follow, and you definitely don't want to miss it. And now let's move on to talking about a virtual network functions as a service. So this is a notion that Tom Knoll advanced, and I want to talk a little bit about it because it's so interesting. So basically, Tom for a long time has been saying that the cloud and NFV have a lot of commonality. And for example, NFV is expected to be hosted in the cloud. When you virtualize functions on standard hardware on servers, you may as well just use the servers in the cloud rather than building sort of custom COTS-based server boxes to do virtual network function and to implement that. So it's going to move to the cloud. And NFV, like the cloud, is about offering services. In fact, that's because it's really the story is about chaining virtual network functions to create new services. And in that context, I want to point out an interesting discussion that I'm having right now with a colleague from Telecom Malaysia on the SDX Central website. Let me screen share that and show you all what's going on. So this is a discussion that I'm having with Ahmad Samsuddin, who's a senior researcher at Telecom Malaysia. And he posted a very interesting question about how service chaining should work and how it's currently working with the vendor that they have currently in place. And we're still sort of thrashing through some of the models that Ahmad is proposing. But this is an important sort of commonality between, if you will, NFV and the cloud. And the cloud is basically about offering, X as a service, where X can be infrastructure or software or platform as a service. So now the question that Tom proposed is, can we actually put virtual network functions in the cloud and offer VNFs as a service? And the answer is that technically that's possible. What that would mean is you would require elements that can be multi-tenant, that can serve multiple tenants at the same time. You would require what is called functional orchestration, which basically means you're separating the virtual network function, what it actually does, from the way it's implemented. It could be implemented in a box, which is a COTS-based server, or it could be implemented somewhere in a server, real or virtual, in the cloud. And those two are separated, but you would have to functionally orchestrate these elements. You'd have to manage it through some kind of an out-of-band interface. And you would have to kind of derive a picture of what these VNFs are doing. So the way you would do that is that to build a management view of these VNFs as a service, you would have to synthesize that view by running maybe a query against some kind of a big data repository that had information about the status of these VNFs as a service elements and potentially other elements in the network. So the question then is, okay, we can implement that technically, makes sense. But then does it actually make sense in terms of bringing something new to the operator? Because that's a question we've been asking, how do telcos transform themselves? And the answer is that usual network services really focus on, incorporating and working with data plane elements. And they are data path centric in that there is a persistent relationship between the sort of end sites and the users, the sites that are forming the network, be they the data center or part of the cloud or part of the actual WAN that's interconnecting the data center of the user and the user. So you have a persistent relationship between them. But when you want to go to a virtual network function as a service model, it would probably work better in a situation where you have a transactional element in the network service. And so what are the kinds of services that have that transaction element? The first thing that comes to mind is a mobile service, where you are basically looking at, it's a content and an event-centric model. So mobile services are basically event orchestrated. Some event happens, a mobile user does something, and it's based on the content they're accessing and the actual action that they've done. So that's a more transactional relationship than a persistent session as you might have in a more standard data network. So it's that kind of environment in which the VNF as a service model comes to play. And I of course encourage you to go read Tom's blog and some of his related blogs to get a better picture of this thought process, which I think is very interesting. So related to that, I also wanted to, in the same breath, talk a little bit about the Cisco numbers that were published earlier this week and what really that means for our industry. So let me just get my notes here. So Cisco announced extremely good quarterly results, as you all know. In fact, if you look at the three main segments that have been most profitable for them, that's switching, routing, and the unified computing system, which is basically the sales of their servers, server software, and the associated infrastructure that goes into data centers. Now, the interesting part is that the unified computing systems were up 40% year over year. Routing was up a mere 2%, and switching was up 11%. But if you look at the distribution of the revenues, the UCS revenue was $850 million, whereas the routing revenue was about $1.8 billion. That's about twice as much. And the switching revenue was twice of the routing revenue, which was $3.6 billion. So the question then becomes, what does this actually mean? For the industry going forward. Now, if we are going to believe that one of the single largest sources of data center deployments and new server deployments is going to be sort of NFV technology, then if you look at how the vendors Cisco and VMware stack up, you'll see that Cisco as a server vendor has a growing UCS business. They're selling hardware. And so they potentially have a big upside as NFV gets incorporated. As we just discussed a moment ago, you start incorporating NFV as virtual network functions as a service in data centers. Clearly, there's a huge sale of servers. The VMware, on the other hand, is a platform software that runs on a server. At least that's the case today. So the servers are clearly much more expensive than the software is. And unfortunately for VMware, the kind of software that they're trying to sell, the operators are actually looking for open source options to many of those functionalities. So the precise thing that VMware wants to license to the operators, or could potentially license to operators, is exactly what the operators are trying to go to the open source movement for. So then we have kind of a dichotomy about how VMware adapts to this. And again, there are many sort of industry prognostications on this. So I'm not going to get into that here. I basically just wanted to bring to your attention the fact that there is this dichotomy. If we assume that this virtual network functions and NFV is going to be the way forward in the next several years, and there's a whole slew of companies that are on the NFV bandwagon today. And of course, Cisco and VMware we talked about. There's also Oracle, surprisingly. There's ALU, there's HP, and so all of these players are going to be vying for this space. And this is something you want to watch out for. So that is what I wanted to talk about in terms of NFV. The only last point I wanted to make with respect to virtualization is a very interesting post actually that was, and let me share that with you so you can actually see what I'm talking about. Let me see if I can get my screen share going. So this was a post I just wanted to bring to your attention that was posted by Javier Viciedo, who actually works out of Sweden. And Javier's whole point was that so far in terms when we virtualize the network, we've been actually virtualizing the OS, and that has some resource issues because you have to have a hypervisor running, you have to have multiple layers within the host operating system to be able to actually create virtual machines. Yet there are interesting alternatives. For example, containers that are also feasible alternatives to OS level virtualization. And the advantage of containers is that they run on a single operating system, so they don't really need hypervisors and multiple layers in the host OS. And they can actually run multiple isolated systems on a single host. But somebody may ask, well, Solaris zones, Linux containers, FreeBSD jails, these are all forms of containerization that have been around for 10 years. But they were not, why were they not popular? And the problem was that they had some limitations in the way that they could actually provide security and isolation. And we needed, that is sort of a cornerstone of the multi-tenant designs that you want in a virtualized data center, for example. But today, that's not the case. We've made a lot of progress, and a lot of the holes in these areas of security and process isolation have been bridged. As a result, it should be possible to actually look at containerization as an adequate option for virtualization. And then very, very quickly, guys, let me go to the next topic, which is data center design. And all I want to do there is point out an interesting white paper that was published and that was announced on the Carrier Ethernet group. Let me again show you that one, which talks about data center design, technologies. And if you look at the table of contents, it does a nice job of covering sort of the move from a three-tier data center design to a leaf and spine architecture that's very popular today. It talks about the role of white boxes and many other design considerations in terms of scalability, L2 and L3, which is something we talked about in a previous video, and what kind of approaches you can have for your control plane. And then the interesting part is they cover a little bit about the solutions from different providers, which is probably a good thing to look at and get a quick synopsis of. And then they talk about network orchestration. So I think this is an interesting white paper to look at to get a sense of data center design. And in the same breath, let me also talk about a very interesting infographic on that was published again by Jules Pedersen in our group that mentioned that 60% of Asia-based companies, enterprises, are planning to deploy cloud in some way, shape, or form. Yet 30% of those companies are extremely fearful that they believe that the cloud does not provide adequate privacy. And if you look at the infographic, which is linked to from the mind map and provided in Jules' talk, his presentation, you'll see it's very interesting facts about how the Asia market is thinking about security and cloud and the interplay of two. So I definitely encourage you to go look at that. And then the last point that I wanted to cover tonight, guys, was the area of small cells. And small cells, as we all know, are a means to increase access speeds and improve coverage. And they go all the way from femtocells to microcells, depending on the size and the range and so forth. But the basic idea is that you have low power antennas and radios that are brought much closer to the end user to improve your access speeds. And there are two sort of competing places where small cells are used. One is in the so-called not spots, not the hot spots, not spots, which are basically what you can deem of as concrete canyons where you have high rises, you have a lot of buildings, and you want to use them inside of the buildings or in between buildings in the street somewhere, and you got a hotspot, you cannot get a cellular signal there. So a good place for those kinds of things are stadiums, malls, a lot of office buildings. And then the other extreme where you need small cells is in the rural areas where actually building out sort of towers and fiber and so on can get expensive. And you might be able to extend the reach and range of the cellular network by using small cells. And the two key hurdles to deployment of small cells is one is that the physical backhauling from the small cell back to the network, to the operator network. You got to think about what solutions you have. I mean, you may not have fiber everywhere, so you're going to have to actually use wireless backhaul, millimeter wave and microwave technologies. And the other is the actual physical installation, surprisingly, because small cells are installed in publicly visible places many a times, and so they need to kind of blend with the aesthetics as well. So these are kind of the two drawbacks to small cell deployment right now. And so this is essentially the topics that I wanted to cover, which we didn't get to cover in part one. So I hope you've got a good sense of many of these subjects. As I've always said, there's a mind map, which I should actually, I didn't share that with you guys. So let me quickly do that so you know what it looks like. So the mind map is going to be available as always as part of the presentation. It'll be a clickable mind map. And if you click, you'll see all of the discussions that I was focusing on. And I've also not only done that, we've also attached some interesting references to many of the discussions. So you can go and look at, the references or other things. So especially in IoT, which I didn't discuss in this part, I put a reference to alternate viewpoints that alternate with Tom's viewpoint of who thought that network traffic doesn't actually increase too much even with IoT. And I think there are a lot of viewpoints that present a different picture that you should go look at. And then net neutrality, I gave you a lot of references to different publications that are talking about the FCC changes that are coming up, which are worth checking out. So that brings me to the end of this roundup. As always, I hope you've enjoyed it. If you have comments, please comment on the LinkedIn group or send me a message on Google+. And until next time, may the bits in your bytes and the bytes in your packets be profitable. I'll see you next time.